Hello, my name is Alex Chatfield. I live in Lincoln, Mass, and I have been on the steering committee for the Coalition to Stop Private Jet Expansion at Hanscom or Anywhere. And I want to first start by giving credit for putting this wonderful program together to our incomparable staff. And that includes our coordinator, Katie Winchell, our tech master, Lily Worthley, and tonight's tech supporter, Laura Sullivan, who will also be our question wrangler. We are so excited to let you know that we have 359 people registered for this webinar from all across the state, from Boston and Salem to Florence and Wendell. And we reportedly have a registrant from Los Angeles and one from Vancouver. So this coalition gets bigger every day. During our program, if questions come to mind, please add them to the chat. You can find the chat icon at the bottom of your screen. Just feel free to type them in, and we will be monitoring the questions, and we will have a question and answer period at the end of the presentation. So what I'd like to do first is to thank our wonderful sponsors. You can see how many of them there are on the slide. A special shout out to our statewide sponsor organizations who've been invaluable in our work, the Sierra Club of Massachusetts and Mothers Out Front of Massachusetts. And for tonight, we have a special thank you because we are joined by tree protection and preservation organizations from around the state, including Trees as a Public Good Network, Restore the North Woods, New England, Save Massachusetts Forests, Standing Trees, New England, Community Land and Water Coalition of Southeastern Massachusetts, the Minerva Action Group, and the Wendell State Forest Alliance. So we are going to have a very wonderful, busy program tonight. We have a lot of information to get to. I will just give you a little preview, which is that I'm going to give a brief recap in the beginning to share with you about the proposed expansion of private jet facilities at Hanscom Field. And that will help place the evening's webinar in context. Next, Dr. William Moomaw will speak about Hanscom and the irreplaceable value of mature trees for curbing climate change. Then Melissa Brown will brief us on 3 pending forest protection bills at the State House and actions that you can take to move those forward. We'll have a question and answer session at the end, and as I said, feel free to put questions in the chat throughout the webinar. We will do our best to answer them. And if you want to direct your question to a specific person, please add that person's name. Then we'll have some concluding remarks, including information on how you can help us achieve our goal of canceling the Hanscom expansion and preserving the acres of forests which adjoin it. And we want to end by 8:30, and we will try to do our best to be on time. So next slide, please. Great. So some of you have heard this presentation before. Some of you, this may be brand new. If you want more information about this project and a myriad of other issues about private jet aviation, we have a wonderful website, which we will tell you about. But the site plan that you see is for Hanscom Field, which is located in Bedford, Mass, near Route 95. And that is the second busiest airport in New England. And it is Massport's general aviation airport, which means that it takes a huge percentage of the private jet flights in and out of the area. And the site that you see highlighted in yellow is the site where developers and Massport have proposed to build an enormous expansion of the private jet hangars at the airport. In fact, it will be a doubling of those facilities. So let's look at the next slide. It is truly going to stretch your imagination to think about how large this project is. It is 2/3 of a mile across. It involves acres and acres of pavement, I think 28 or 29 acres of pavement just to facilitate the taxiing of the jets. There would be 17 new buildings in addition to the existing old Navy hangar that has been there since the 60s. And in the upper corner of the screen, you can see they are planning a fuel depot, which will have four 20,000-gallon jet fuel tanks, which will be delivered along Hartwell Road. These hangars have been touted as being green facilities. The developers have talked about making a plan to put solar panels on them. They're trying to tell us how they will be LEED certified, and claiming that this is some sort of environmentally friendly project, even though the entire purpose of them is to facilitate private jet aviation, which is the most polluting form of transportation per passenger mile that has ever been invented. Next slide, please. And just to connect the North Airfield project to the purpose of tonight's presentation, which is to talk about trees, what you need to know is that the site as it exists today has trees abutting it and on it. And the developers cannot build these facilities without cutting down over 20 acres of trees, some of which are nice, large, mature trees. Now, they are saying that they have a plan to sort of mitigate the impact of that. But I think as you listen to our speaker tonight, you're going to realize that that is not a credible way of making up for the harm that they're planning to do. Okay. So you might be wondering, what is the actual connection between this North Airfield project and the subject of this talk, which is trees and how they are helping prevent climate change? Our coalition was formed 3 years ago as many members of our communities came together in the name of climate protection to oppose this dangerous, unnecessary, and wasteful project. And from the beginning, we have kept a laser focus on how the project will impact climate change. The developers have claimed that the proposed 500,000 square feet development on nearly 50 acres for 17 new jet hangars will be environmentally beneficial, that it will reduce aircraft operations and decrease greenhouse gas emissions, and that they will work with the town of Bedford to offset the removal of the 20 acres of mature trees by replacing them with other trees in a more project-convenient location. If all that sounds like gaslighting to you, that's because it is, as they say where I grew up in Ohio, hogwash. This webinar is one of a series of educational resources that we have provided to the community, and we're delighted to have these eminent speakers with us to illuminate the web of connections between preservation of trees, protection of our climate, and the dangers posed by reckless development and runaway carbon emissions that are endangering humans and all our fellow species and ecosystems. To sum up our message, it is SPJE's view that destroying climate change curbing mature trees to make way for super emitting private jet expansion is indefensible and irrational. Now I would like to introduce our first speaker. William Moomaw is Professor Emeritus and Founding Director of the Center for International Development and Resource Policy at the Fletcher School at Tufts University, and Distinguished Visiting Scientist at Woodwell Climate Research Center. He received his PhD at MIT in physical chemistry as a member of the chemistry department. And as a member of the chemistry department at Williams College, he directed the Center for Environmental Studies. He served as a Congressional Science Fellow and worked on the legislation that banned CFCs from spray cans and on the 1976 National Forest Management Act. He was a 5-time lead author of the IPCC reports addressing the science and technological mitigation of climate change, including the 2007 report that shared the Nobel Peace Prize. He was elected a Fellow of the American Association for the Advancement of Science for his, quote, outstanding contributions to our understanding of climate change and its global impacts and to the work of Intergovernmental Panel on Climate Change, unquote. He is currently working with forest ecologists and wetland scientists identifying opportunities for natural climate solutions. Working with an architect and engineer, he and his wife, Margot, built one of the first engineered net zero energy solar homes in the Northeast US that uses just 20% as much energy as a code-built house. Solar panels provide electricity for a ground source heat pump that heats the house and provides hot water and all the lighting and appliances. They have exported surplus electricity to the grid over the past 18 years and have fueled 2/3 of the miles driven by an electric vehicle for the past 8 years. They protect 12 acres of forest and wetlands. Dr. Moomaw, the floor is yours.
Thank you very much. First, I want to thank the organizers who have done an incredible job of pulling together this many people. I'm delighted there are this many people who are interested in this topic. And the fact that it is happening in one location, but is drawing interest from all over the continent is really remarkable and a very good sign. Let me bring up my, let's see, let me do my screen share here. And then get the slideshow going. Why is this not?
Hi, if you hit the play from start button on the left side, I think you should be able to get it.
Play from start. Where is that?
On the left side.
I just have home.
Yeah, down below.
Oh,
home.
down here. I see.
Yeah.
There it is.
Yep.
There it is. Thank you.
You got it.
Okay. Is that working now?
Yes.
Okay. Well, thank you for that nice introduction, and thank you for all the people who are interested and engaged in this particular issue. Let me just give you a quick outline of what I plan to do. Some consequences of the Hanscom development will be the first thing. You already heard many of those from Alex. I just wanted to have them in a condensed form so that I could refer to them. Then I want to talk about the climate factors, and then why do forests matter so much for the Hanscom project, and why do they matter for climate, and what you can do. And we'll have at the end of my presentation, Melissa Brown telling you what you can do for things here in the Commonwealth of Massachusetts. You've already seen a map of this area. Just to remind you, here are the runways, and this is the area that will be developed. And here are the Great Meadows National Wildlife Refuge here, and the Minuteman National Historical Park here, and Walden Pound down here, and look at all the adjacent people. And according to the developer, none of that will be disturbed. In fact, it'll be enhanced by this project. So here are some statements by the developers. I just had to put these in. You already got the drift, I think, from the introduction. So the proposed action is not expected to result in a significant change in operations or noise impacts. Increasing the number of jet flights coming in and out without any increase in noise is a remarkable achievement if they can do it. The project will be designed, as you heard, to meet LEED building design and construction. The operation buildings and so forth will be a tiny fraction of the energy and the emissions from this project. It's all about the planes. And they're going to do great things for the stormwater. They better, because they're going to pave over a huge area and there'll be a lot more runoff that will come into the neighborhoods that are adjacent. Designed as the aviation facility of the future, it will provide technologically advanced infrastructure for clean and sustainable aviation that is anticipated. And finally, it will facilitate progress toward a net zero greenhouse gas aviation. They have some rather remarkable, I guess I would say, claims about how those offsets will work that have all been debunked. So, by the way, GHG means greenhouse gas. Those are the heat trapping gases in the atmosphere, which carbon dioxide is the largest one. So the Hanscom expansion does remove trees. It increases regional pollution and it compromises biodiversity. And here I'm just reiterating what you already heard about the hangars, building more hangars, so there'll be maybe twice as many or more jets using the airport. It's already the second largest used airport in New England. And this will guarantee it will hold on to that place into the well-known future. There's specific forests that they acknowledge will be removed, but don't worry, we will plant trees. And I'll tell you why that's not going to solve the problem. And there's very little in their considerations about the additional fragmentation and disruption of the surrounding environment and the biodiversity. So what is biological diversity? Well, here's some pictures of forest biodiversity, and I specifically chose, obviously, trees on the left. As we think of forests as trees, but forests are not just a bunch of trees. They are the most biodiverse ecosystems on the planet. I made the mistake of saying to an ecologist in Australia that isn't it remarkable that forests host 80% of terrestrial biodiversity? And she corrected me and said, you have it backwards. It is the other way around. Forests are biodiverse ecosystems. That's what makes them so resilient to change. In other words, all of these things, these ferns, these mosses, these insects, these fungi, plus the fungi you can't see that are underground connecting all these trees to one another, and the animal and bird life. So in biodiversity loss, it's not only just the number of species that are lost, it's also the number of species, the number of individuals that are lost in each species. And we're seeing a huge loss in many bird species right now, particularly some of those that are in the neighborhood of this project. And the process in Massachusetts that is implementing the Endangered Species Act identifies 4 endangered species that are affected. I just put together a list of some names of some of the the bat is one of them, but the various bird species that are indicated that live in this area or nest in this area or here at certain times of year and would be affected. And noise. Well, as I said, if you're going to 6,000 more additional flights, I'm sorry, there just has to be an amplification of noise levels. And the developer's environmental impact review was in fact rejected because it largely ignored these effects. And it won't solve the whole problem, but retaining existing forests and letting those forests keep growing will reduce noise from air traffic, although it will not eliminate it. And then there are the air pollutants from private jet exhaust. I haven't seen a lot of discussion about this, but Here are some of the pollutants. You may be familiar with some of them because they're the same as some of them are the same as those that come from gasoline and diesel powered automobiles and trucks. So there are a bunch of nitrogen oxide gases, compounds of nitrogen and oxygen that contribute to smog. And this is especially bad when planes are taxiing, taking off or taxiing or idling. And because the fuel contains a certain amount of sulfur, there's sulfur dioxide, which maybe many of you will remember was the big cause of acid rain, which we brought under pretty good control until this year, when it looks like the president is eliminating those requirements. But we know how to deal with sulfur dioxide, but we don't know how to deal with it as jet exhaust. And jet exhaust puts out a lot of soot, black carbon, and ultrafine particulates that are especially harmful to human health. These are, if you look at the health impacts of air pollution, these are the ones that are causing the most problem and the most disabilities and the most deaths. Then carbon monoxide, which is harmful to respiration, and it also takes part in air pollution chemistry. That's because of incomplete combustion of the jet fuel as it's burned. And then there are some other carbon-containing molecules in jet fuel don't get completely burned, and so they're released as well. And they are what combine with the nitrogen oxides to form smog. So smog will increase in the area if this project goes through. This is a very busy slide, but this is all about climate, which is getting closer to one of my main topics here. So there'll be roughly 6,000 additional flight operations, adding something between 134,000, 161,000 additional tons of carbon dioxide equivalent, it says, which means not just carbon dioxide, but other gases that also trap heat. And the developers' claim is that, well, these ferry flights, which means that the plane is not where the owner is, and so it has to be flown empty from where it is to where the owner is. If we put more hangars here, there will be fewer of those. Well, the analysis was done, and it was ludicrous. I mean, it was an infinitesimal amount of jet fuel saved and emissions decreased. The one that really the points that really get to me as a climate scientist are that private jets emit 5 to 14 times more per passenger mile than commercial economy class. And the second one after that, if the project goes through, the emissions would basically be equivalent to the benefits of 70% of the solar panels that have ever been installed in Massachusetts. In other words, the savings from that would move us backwards by 70% from where we would have been if the planes were not there. This is just the extra part. So there's also a similar amount of emissions coming out now, which means, again, compared to our rather pathetic solar installations, it's already taking its toll and making it harder for Massachusetts to meet its climate goals. The claims, there are a lot of claims that, and unfortunately the governor seems to have bought into this, that there may well someday be electric planes, but they'll be rather short range planes. But sustainable aircraft fuels made from crops means it won't be fossil fuels that are burning and putting carbon dioxide in the atmosphere. It'll be carbon dioxide coming from burning plant material, plus all of the carbon dioxide and methane that's emitted from agriculture itself as a process. And so, first of all, studies have shown it's unlikely this will be achieved in the next 25 years, and I would add, if ever. Currently, there's a study analysis that shows that currently the sustainable fuels that have been developed for aircraft are increasing emissions above those of fossil fuels because of all those extra emissions that are associated with the agriculture. So what is this climate that we're so concerned about, and why is it important? And this is an arbitrary definition, but it's a useful one that's been agreed to by, I think, all the scientists who work on this in the world. That climate is the 30-year average of weather. That is temperature, humidity, rainfall, snowfall, wind, seasonality, conditions, and so on. And as one of my colleagues put it, climate informs us how to pack our suitcases when we travel, and weather is what we find on the days we are there. In other words, what weather at a location is seldom the average of all the inputs. It varies so much, as we are seeing here in New England in the past few weeks. Pretty extraordinary. So let me just show you an area. You can look at that and you can see what kind of climate they have. It's a desert climate, and that's Phoenix, Arizona. And because it's in the news lately, this is Nuuk, Greenland. Very different climate. The two are on the same planet, but they have very different climates. And both of them are seeing changes in the climate. So in Phoenix, in 2024, saw 70 days that exceeded 110 degrees Fahrenheit. In 1900, it was just 5 days. And in 2010, it was 27 days. It would be hard to argue that the climate of Phoenix has not changed. Just to argue that it has not changed. It has clearly changed, and much for the hotter. Greenland is losing its ice sheet. And this is just showing from 2002 to 2024. And this is in billions of tons of ice that are lost. And just in that short period, it has lost some more than 4,000 billion tons of ice. And if all the ice on Greenland were to melt, sea level would rise about 21 feet. And I think Boston wouldn't be with us anymore. Here are just some other examples of how climate has changed and is affecting lands and oceans. In the upper left is Situate, Massachusetts, 2018. It's a great advertisement for oceanfront property if you really like your ocean close. This was a special high tide and a storm surge that occurred that year. 130 degrees in Death Valley, California. Wildfires everywhere. This happens to be in France in 2022, a country we don't think of as having vast forests or forest fires. To me, perhaps the most notable climate-related event in 2025 was Los Angeles fires. 16,000 buildings burned, and a lot of lives were lost, and a lot of surrounding forests and grasslands were burned. Now, if you were fortunate enough to be in downtown Boston on the waterfront in 2024, you could have gone to this restaurant and had a seaside drink and meal, and there was an exceptional high tide, but nevertheless, it's a high tide on top of a higher ocean. And then Hurricane Helene in 2024, with these very high winds. Oh, I forgot to change that from kilometers to miles per hour. It'll be about, I don't know, more like 200 or 100 and, 200 and some, almost 200 miles per hour. And what's unique about this was it increased in intensity more rapidly than any hurricane that's ever been seen. I mean, within 24 hours, it went from a very, maybe 75 miles an hour to 180 miles an hour. It really increased rapidly. You're all familiar, I think, with the way that the heat trapping gases trap the heat. The sun shines, but there's one subtle point here that most people don't really understand, and that is, so sunlight comes through the atmosphere, it's transparent, and some of it's reflected back by clouds, and some by the oceans, and by snow and ice, and so on. And that heats, but about 2/3 of it gets through and warms up the Earth. This indicates the Earth is warming. As the Earth warms, it radiates more heat back into space, and some of it gets out to outer space. But some of it is absorbed by greenhouse gases like carbon dioxide and methane and a number of other gases, and is re-radiated. And half of that radiation goes out to space, but half of it comes down to Earth. And the amount that comes back to Earth on a given day from the atmosphere is equal to or greater than the direct amount of energy we get from the sun. That's a really astounding consequence, I find. So here it is. So here is what's happened to atmospheric carbon dioxide since 1800. The Industrial Revolution was just a couple of years back here in 1750. So it was pretty stable for a very long time. It began to rise around the end of the 19th century. In the early 20th century, it rose a bit. And then after the Second World War, it just skyrocketed. And as we'll see in a moment, in 2024, it led to the warmest year on record. So here are the temperatures. Each dot represents the average temperature of that year, and the lines represent the uncertainty. The uncertainty gets less and less as we come toward the present because we have many more stations, and we can measure with much greater accuracy. And so we can see here that in 2024, we exceeded 1.5 degrees Celsius, which was supposed to be the boundary we would not exceed in this century. Dropped off a little bit in 2024, but as you can see, it goes up and it goes down. It will be back up again, no question about it. And the carbon cycle, this looks complicated, but these are the human-caused flows of this is in billions of tons of carbon. And here are all the fossil fuels, coal, oil, and gas. And each year they put 9.8 billion tons of carbon into the atmosphere as carbon dioxide. The harvesting of forests and the destruction of plants on land adds another 1.4 billion tons. And so you add those together and you get 11.2. And then what's amazing is the increase in the atmosphere is only 5.6. So what is happening is there's there's just half as much. So an equal amount is currently being removed. 3.2 billion tons from the oceans, by the oceans, and 2.4 billion by primarily forests and other plants on land. So and scientists have known about this, that only about half, the increase is only about half of what we put in, but it's taken about 25 years to really be able to put together a figure like this and show where it's actually coming from and where it's going. So being very concerned, governments have been meeting and talking about this problem for a while. And so in 2016, they all got together, and every country in the world, a government in the world, including the U.S., agreed that we should do something. We should not allow the temperature to rise more than 1.5 degrees Celsius. That's 2.7 degrees Fahrenheit. Doesn't sound like much. But then the diplomats turned to the scientists and said, okay, so what do we do? How do we do that? And this report came out in 2018, and it was very clear. This is I don't know, it's about a 100-page report, but here's the punchline. To keep temperatures from rising above 1.5 degrees Celsius, this is the quotation, global net anthropogenic carbon dioxide emissions must decline, actually I added must, by about 45% from 2010 levels by 2030, reaching net zero around 2050. The tagline that everyone remembers is net zero by 2050. And so we have all these plans, all these, we have one in my town, it's the Net Zero Committee and so on. But people forget about this need to decline by 45% by 2030. Otherwise, if we get to net zero at 2050, there'll be too much carbon dioxide in the atmosphere, and we will have a temperature that's well above 1.5 degrees. So net zero means that's when carbon dioxide additions to the atmosphere from all sources equals removals by nature. So there's no further change in atmospheric concentrations. So where are we? Well, in 2023, the Intergovernmental Panel on Climate Change came out with this new report. And here's the figure from that report. It says that basically limiting warming requires rapid, deep, and in most cases, immediate greenhouse gas emissions reductions. And so here we are. Here's 2020, 2022 is right about here when this was done. And so this is what we'd have to follow if we wanted to stay within 1.5 degrees. In other words, this means by 2030 we're down by 45%, and then we're down by 2060 we're down by 80%, and we level out by 2100. If we want to limit the warming to just 2 degrees, a little bit more, then we still have to reduce it pretty rapidly. Where are we now? And with the commitments that have been made by governments, this is the path we're on right here. This is sort of uncertainties because we don't know how those will change over time. But this phrase here says, implemented policies result in projected emissions that lead to warming of 3.2 degrees Celsius. Well, that is probably approaching unlivable for many parts of, in fact, it will be unlivable in many parts of the world. And so that is just not going to get us there. These are what we've said we're going to do, and it's not what we're actually doing. We're not even doing what we said we're going to do. So we've got to have these large removals in early years. So if at one of the recent meetings, the delegate from Vanuatu, which is an island nation in the Pacific, made these comments. He says, if we overshoot 1.5 degrees, which we've already done once, no level of finance can pull back the sea in our lifetimes or our children's. There is no rewind button on a melted glacier. There is no time machine for an extinct species. Pretty powerful statement. Once we cross these tipping points, no amount of later cooling can restore our sacred reefs. It cannot regrow the ice that already vanished, and it cannot bring back the species or the cultures erased by the rising tides. There was dead silence, I gather, at that meeting. I mean, this is it. And just to add to that, in 2009, Susan Solomon, who's a first-rate physicist at MIT, published this research paper in which she pointed out that we are stuck with very hot, with whatever the peak temperature is, whatever the peak concentration of carbon dioxide is when we decide to start reducing it. The amount that stays in the atmosphere stays there for a very long time. This is 2000, and this is 3000. This is a 1,000-year period. And this is the baseline we are coming from down here. So we are up here now. We're approaching 450 right now. We're at 425, 6, something like that. So that means that we will be still above 400 parts per million. And the consequences of that are that the global average temperature, this is the best we could do, will be, we could probably just barely stay below 1.5 degrees if we were able to stop in the next 2 years, let's say, of adding any more. But it doesn't look promising. Well, then why don't we just remove carbon dioxide? And there's been a lot of talk about direct air capture. We're going to build machines that are going to suck up air and take the carbon dioxide and store it somewhere. And that'll be that way we can beat that pessimistic possibility. And so this is just showing the actual recent measurements of the carbon dioxide in the atmosphere By the way, these are going to end because they're going to shut down this station, the government is, but this has been going since 57, I believe. And it oscillates by the month because of this is in Hawaii, so it's northern hemisphere. So in the spring and summer, the atmosphere concentration goes down because there are trees sucking up carbon dioxide. And in the fall and the spring, the levels are higher. And this is the line that comes in as the average. So what is 1 part per million? So remember, we have out of every million molecules of air, we have here, what are we talking about here? Something like 424 parts per million. We want to reduce it to 423 parts per million. But 1 part per million is 7.8 billion metric tons, which are 10% bigger than imperial tons that we use. So it's a lot. It's a big amount. And the increase, in addition, the increase from December 2024 to December 2025 was 2.1 parts per million. That means to reduce 1 part per million below 424 to 423, we have to remove that 1 billion tons plus the 2.1 that were added, or 3.1 billion tons, which is 24 billion metric tons of carbon dioxide. Current cost is $500 to $1,000 per metric ton, which is 12 to 24 trillion dollars. And that's 10 to 20% of the current gross world product of $117 trillion. That's just a little calculation I put out just to suggest that maybe this is not going to be the solution. So what is the solution? So here's the largest direct air capture system in the world. It's in Iceland. It's a very cool piece of technology. It's called Mammoth. And it is removing 36,000 tons of carbon dioxide per year. Actually, it's not clear that's been achieved yet, but that's what it's supposed to be. And but global forests are removing 4,250 million tons of carbon dioxide per year. And so let me ask you, which one is likely to do the better job? And what would do a better job if we could increase the amount from forest at a fraction of the cost of building something like Mammoth? Like there's a super Mammoth that's going to be removing 1 million tons a year, but 1 million tons is still only, a millionth of a billion tons. So we're not going to do it. And by the end of 2025, Mammoth hasn't removed its own operating carbon dioxide because it does get electricity from the grid. So what if forests had not been removing about 30% of fossil fuel carbon dioxide emissions to the atmosphere annually? So we can see here's the temperature over here. It's been rising. And the Met Office, which is the office that covers climate change and climate in the UK, published this in 2021 because 2021 was a landmark year because it marked a 50% increase from the pre-industrial level of 278 parts per million. So it's now 50% bigger at 417. And so we would have reached that if we hadn't been removing 30, if forests hadn't been removing 30%, we would have reached that back here around 1960. And of course, the obvious next question is, where would we be today? Watch carefully. 542 parts per million. And that's almost double. So why do forests matter? Well, they're already doing an incredible job, but they're always often thought of as a natural resource. We refer to them as natural resources. Most states have departments of natural resources that manage their forest. And that means if it's a resource, it's to be managed sustainably to produce the greatest economic returns. Or they are also, forests are cleared for the expansion of agriculture and urbanization and a lot of other things. So 1/3 to 1/2 of the world's original forest area after the last ice age has been cleared for these two purposes. That is either for products, timber, paper, or to make way for more of our urbanization, suburbanization, agriculture, roads, and so on. So these two forms of exploitation, along with soil degradation, have added about 1/3 to the increased burden of carbon dioxide in the atmosphere. So reducing that exploitation would help us on the addition side of carbon dioxide to the atmosphere. So let's just look here and see what our what happens when we take forests as a natural resource. This is an actual photo. This forest isn't really a forest. It's a bunch of trees. It's a plantation. If you drive Route 2, as I do frequently from Western Mass into the Boston area, right through the Concord Rotary, which I wish would get fixed. These are all trees. They're all the same size. They're all the same species, and they're all being harvested with this machine that is designed to just take them and put them in the right lengths to put in the sawmill and make into boards. And so there's a huge amount of waste in this process. In fact, only about 1/4 of the carbon, by the way, wood is about 1/4 carbon, is about 50% carbon by weight, but only about 1/4 of the wood that in the tree that's harvested actually ever makes it into a final product, like a 2x4 that goes into a house. So when people do their accounting, they often don't take that into account and talk about that part. So anyway, here we are. We're exploiting this as a resource, and so it's all economics that decides what they are and when they're harvested. Very little biodiversity in this forest of any kind. Certainly not in the trees. So they're to be utilized for economic gain. And we will continue to do that. And so it's great that we need to be great about learning how to do it as effectively as possible. So there are few old growth forests remaining in the United States because this has been going on very heavily for a long time. And just to give you some, these are from the 1890s. This is Vermont. These are the Green Mountains of Vermont in the 1890s. Vermont and Massachusetts were between 80 and 90% deforested by 1900. But look at this log drive. Those are all logs in a river, in the White River near Sharon, Vermont, 1900. Here's a mill where they're. I mean, it's just incredible as they're sending them down the river as products. And as a result, New England. This is the average for all of New England, this gray line, saw sort of a gradual decrease because forests were harvested for fuel and for wood. But then as the Industrial Revolution got started, it really increased and was more and more. And by 1850, between the sheep culture and the demand for timber, it had decreased down here to by more than down here about 55%. Some states, for example, this is New Hampshire, was 70% deforested, and then they all started coming back. And then look at Massachusetts. So here's Massachusetts, this blue line here, and this blue line here had this really big drop, and then it came back, and then sometime after 1950 it started declining again. So this is area. This says nothing about the quality of the forest in those areas. So this is just an area. This is just showing that population in New England just increased inexorably. And the result was a dramatic change in the animal species in the northeastern forest. All the carnivores decreased dramatically, and virtually none of them came back. The bear has come back, but here you have, interestingly, deer and moose dropped quite a lot, and then of course deer have just come back in a huge recovery to the point that they're actually jeopardizing the return of existing forests because and after this winter, I'm sure that they've even munched on more saplings that they could find in the snow. So there's a real problem here that we've disrupted the ecosystem so badly in terms of species composition that some species are now damaging the very system that supports them. So why do forests matter for other purposes? There's a second perspective that treats them not as a resource, but as essential components of the Earth's operating system. They and all other ecosystems share this role, as I'll show you in a moment. And so they have limited, as I said, the annual atmospheric increase by over 30%. And one way to talk about them as essential components is that they are vital organs of a living planet. That may sound a little metaphoric, but this is a living planet. It's quite a remarkable mega organism of its own. And so there's no technological solutions that even come close to nature's solutions. That's what we have to remember. So we keep turning to technological solutions like the magic of direct air capture or building nuclear power plants, which take 15 years and cost billions of dollars. And we need to do some of those kinds of things, but it's going to be solar panels and offshore wind and other things that are going to make the difference, super efficiency and the like. And in 2016, there was an organization called Trillion Trees. It was to advocate for increasing the Earth's estimated 3 trillion trees to 4 trillion trees. We're going to plant trees. And this restarts a harvested or cleared forest land. It may eventually achieve the original biomass, but it takes just the first 20 years of newly planted trees to absorb the carbon dioxide that the soil respiration is emitting. In other words, all the bacteria in the soils are chomping on whatever organic matter is there and releasing carbon dioxide to the atmosphere. And there are other bacteria that are converting it into soil carbon. But it takes over 20 years for newly planted trees to absorb carbon. I'll show you an example of that in a moment. And then afforestation is when you just start a new forest somewhere where none was growing before, or certainly hasn't been recently. And it takes a lot of time and it takes a lot of land. It's very expensive. So back in before 2020, I and some other people began thinking about this, and I found that there was a lot of research just showing how effective existing forests were at removing carbon and storing it, and said, well, what would happen if we let more forests grow? And so I instead of defining forest management as sustainable forestry for the ongoing production of wood products, if we defined the goal of forests as achieving their ecological potential for biodiversity and carbon accumulation, trees and soils, we would actually remove a lot more carbon. And the other bit of mythology was that we should get rid of these big old trees because they're going to die anyway, and plant those little trees you see in the background here because they're going to be vigorous and active. But of course, you can see there's not a fraction of the carbon in that little tree as there is in this big tree here. And so these older forests with these very big trees are highly biodiverse. All the components are there. And here's the punchline message. Large trees store vastly more carbon than lots of smaller ones. And these are the equivalents. My colleague and friend Bob Leverett put this together based on measurements he's made and the use of some of the models that the U.S. Forest Service uses. So if you have a big red oak, it's 100 feet tall and 54 inches in diameter. How many trees that are 50 feet tall, which will only be 12 feet in diameter, 12 inches in diameter rather, do you have that will to equal it in carbon? And it's 35. And if they are street trees that are 40 feet tall and 6 inches in diameter, you need 151. And if you plant big new landscape trees, not little saplings, but big ones that are 4 inches in diameter, you need 465 of them to equal the amount of carbon here. So when the developer says he's going to plant trees, and often they say we will equate the diameters, but it's the volumes that we need to equate, not the diameters. And it takes a long time. This tree, a tree this big, is 100 years old. And to get one tree to plant, you have to plant something like 22 trees to get one to survive in the 100th year. Now, I wanted to talk about this whole thing here just briefly about the hardwood forest that was harvested. And in this particular case, the wood was burned, so the carbon all went directly in the atmosphere. So we can do a very clean comparison. And you can see this is the drop in carbon that's in the forest. And this amount is the amount that went in the atmosphere. So this little blue line here is the amount that was released. Here it is being removed 45 years later. But if you notice, it's still not the same amount of carbon because of this loss of soil carbon. So you basically have to grow this forest for a longer period of time to get that back. And this is just showing the forest cover in the Northeast in 2020. And you can see that Massachusetts is heavily forested out here in the western part. And the Forest Service confirms that this region, western Massachusetts, southern Vermont, New Hampshire, this is the Adirondacks, by the way, which is a forever wild area. But the carbon density, the darker the green, the more carbon density. The less carbon density per acre, the less that is. Look at Maine, huge area of forest, but only about 1/3 of the carbon per acre as in our areas. Here in the eastern part of the state, it's more checkered because it's more developed in terms of cities and things. So here in Massachusetts, we have forest reserves. You'll hear Melissa Brown talk about this in just a moment. And the importance of it, here's a second one taken in one of our state forests. This is a person standing here. That's a very big tree. And there's always something new coming along. Just a couple of months ago, it was discovered that the bark of trees hosts billions and trillions of bacteria that eat methane, which is a greenhouse gas. A few years back, it was found that wetlands cover only about 6% of the Earth's land area, but wetland soils hold 30% of global soil carbon. There are a lot of wetlands around this Hanscom project. So the IPCC is very strong on this now. Safeguarding biodiversity and ecosystems is fundamental to climate resilient development. Recent analysis suggests that maintaining the resilience of biodiversity and ecosystem services globally depends on effective and equitable conservation of approximately 30 to 50% of Earth's land, freshwater, and ocean areas, including currently near natural ecosystems. And then our papers also cited protection of existing natural forests ecosystems is the highest priority for reducing greenhouse gas emissions. So that's the key message here. And just a little consequence of all this is that the oceans and forests have kept the Holocene era since the end of the last ice age livable in a way it never was before. Before the ice age and during the ice age, the climate was so unstable that people were nomadic. And stable climate allowed people to remain in one place and practice agriculture. And this was followed by permanent settlements, urbanization, and all known advances of civilization. And this process happened independently in Mesopotamia, which is now the Tigris-Euphrates, Iraq area, India, China, and the Americas, within a couple of thousand years of each other because the conditions were not uniform over the whole earth. Some places got more livable than others sooner. And so they maintain this temperature and conditions. And so our forests, the essential components of the Earth's operating systems, they provide the mitigation and adaptation. They cool New England through the evaporation from their leaves. They produce local and distributed rain to distant locations. They reduce flooding and soil erosion. They provide about 1/4 of atmospheric oxygen. After reading this list, I always want to ask, have you thanked a forest today? Um, and so just wrapping up here, E.O. Wilson, the famous biologist at Harvard, wrote his last work was called Nature Needs Half. Protecting and interconnecting at least half of the planet's land and water is necessary to sustain the health, function, and diversity of all life. And this is exactly what the IPCC says. And they come up with a comparable number between 30 and 50%. And our middle-aged forests in New England are doing a lot of work of keeping the place cool for us with their evaporation of water and so forth. And they can clearly affect their contributions will continue towards getting our 2050 goal. They're essential for getting our 2050 goal. And let me just come back to, as I wrap up here, the consequence of the Hanscom expansion for nearby historic places. Great Meadows National Wildlife Refuge will be adversely affected by so many additional flights threatening migratory birds that nest there. It is ironic to me that as the nation approaches its 250th anniversary, the remarkable Minuteman National Historic Park is potentially degraded by the anticipated increase in nearby flights and associated noise and pollution. And oops, here we are. And then there's Walden Pond, and Henry David Thoreau might have an interesting perspective. I think everybody in this, certainly in the Concord area, has been to Walden Pond and have seen this sign, which is a short paragraph from his book Walden, which was so influential. He too noticed the woods. I went to the woods because I wished to live deliberately, to front only the essential facts of life and see if I could not learn what it had to teach, and not, when I came to die, discover that I had not lived. But even when you look at this and you look at the small trees behind it, you can tell this is not an original forest. This is a growing back forest. And so we need to let it grow back. So let the trees in the Hanscom region forest grow and let them become something like this someday. And to do that, we just need more protected areas. Less in Massachusetts, just a little over 1% of our forests are intact and protected. And about 3.5% are intact, meaning that they are functioning forests, but they aren't protected. So let's establish two kinds of forests: strategic forest reserves. Those are two very famous climate forest scientists standing there. And then industrial production forests separately. These two photographs were taken about 25 miles from each other in Western Massachusetts. So we better protect those areas pretty quickly. So here's to wrap up. These people are searching for a climate solution. They seem a little lost. But if they'd only look up, there's a major climate solution growing in plain sight. Thank you.
Thank you, Bill. What a feast for the eyes and the ears. I'm going to be thinking about those charts and graphs for the next few months. That was stupendous.
Thank you.
Learned so many new things. Thanks very much. We're going to move right along. So let me introduce Melissa Brown. Melissa is a retired social scientist, now focusing on forest and urban tree advocacy. She is a co-founder of the Trees as a Public Good Network, a statewide group that advocates for pro-forestation legislation and also supports community efforts to save local forests and trees. She is a co-founder of one such local group, Protect Newton Trees, and we are delighted to have her here with us tonight. Melissa, the floor is yours.
Thank you, Alex. And thank you to you and to the organizers for inviting me. I'm going to share my screen and start with my slides. There we go. So Our organization, Trees as a Public Good Network, was founded very recently, only in 2022. And we base our advocacy on legislative work on the peer-reviewed science of Bill Moomaw and other climate and ecosystem scientists. So it was a delight to get to hear him speak tonight. I hope some of you will consider joining us. Here I have a number of resources that talk about the wider range of the Trees as a Public Good work, but tonight I'm just going to be focusing on regional forests and their relationship to our drinking water. And there's a couple key points to take away from here. First, 40 to 60% of our on-land rainfall comes from regional forests. And that's really important. We'll come back to it. 53% of US water supplies come from forested land. So forests are absolutely essential to our water, and we've come to focus on it at Trees as a Public Good Network because we find that water gets the attention of officials. So this is a map that shows an index of a watershed's ability to produce clean water, APCW. And this is from the U.S. Forest Service, their 2024 version. And it's important to know that this APCW index reflects both the quantity of water that can be produced by a watershed as well as the quality of the water produced. Please note that for this entire region, right, Massachusetts has 0 watersheds able to produce clean water at 100% capacity. And that, you might ask why here, if you come back up here, we see the 100% watershed capacities in New York, the Adirondacks, the Catskills in Vermont, in New Hampshire. Why then are New York, Vermont, and New Hampshire able to have 100 APCW watersheds? This example is just taken from one section of the Catskills, and you can see the overlap in these dark green areas from Catskills Park that is the Forever Wild section with the 100% APCW watershed according to the U.S. Forest Service. So really what it comes back to is that there is no logging in these watersheds. These are wild forests. There is no so-called active management. So when we've come down to a 73% ability to produce clean water, then we get Massachusetts watersheds that show up, including around the Quabbin and in the Berkshires and elsewhere. So one of the things that is the reason for why this is a lower level of ability to produce clean water has to do with state logging of the watersheds. And I will come back to that in just a moment. But I wanted to zoom in a little closer and look at Concord and Bedford area around Hanscom, and all of Concord is getting its water from the the local watershed resources shown here in green that are 53 to 58% ability to produce clean water. So the level at which the water is being produced in the watersheds that Concord is relying on for drinking water is even lower than that of the Quabbin. Bedford is lower yet again. That watershed area is at 43% APCW. Now, only 10% of Bedford has to rely on this 43% watershed level. The other 90% of Bedford's population gets its water from the Quabbin. I'm not sure which section of Bedford is the 10% that relies on this, but you can see that these watersheds are already greatly degraded. So the question then is, how will cutting 20 acres on this left side of the planned development, and possibly up to 5 acres on the eastern end. How will cutting 20 to 25 acres of forest at and around Hanscom impact nearby watersheds? And the problem is that we don't know. There are no adequate studies, not only here, but according to Dominic Della Sala, a forest and water specialist who is at a university in California, he said that there are not adequate studies of this relationship for the eastern U.S. at all. And this question about the impact of cutting forest on nearby watersheds is also not a standard part of environmental impact reports. So we really should be protecting our urban forests until we have a better idea of what cutting them down does to our water supplies. Because when we run out of water, where are we going to turn? To the Quabbin. In the 1980s, people were talking about diverting the Connecticut River to provide water for Boston. That would be an expensive nightmare. Others have talked about, desalinating parts of the ocean. These are expensive and impractical. And on top of that, the Quabbin water is also already vulnerable. This watershed is only producing at 73% capacity, and it lost 12.3% of its stored water, the Quabbin did, between June 1st and December 31st of last year because of drought. That took us by January 1st to within 1% of what is considered drought level capacity for the Quabbin. Now, Quabbin is the water supply for Boston and 40 towns in eastern Massachusetts. And there's an additional 12 towns in the Quabbin area that are petitioning to be able to draw on that. Yet the Massachusetts DCR and other state agencies, they annually log all state-owned public forests. And there are multiple proposed harvests for this spring alone in the Quabbin. So this is further degrading the watershed's capability. And this brings me to the bills. There are 3 bills in the state legislature right now that will require all state-owned public forests to be made into reserves as wildlands that have no logging. And this matters for drinking water levels and capacity in Massachusetts. We are trying, the Trees as a Public Good Network is trying to get these bills attached to the governor's environmental bond bill. This little arrow thing up here is a lovely little step-by-step process for how a bill goes through the Massachusetts state legislature, and the star shows where we are now. The governor's bill is in the Senate the Senate Ways and Means Committee. And that is where we are working right now to lobby. We are lobbying both Senate and House Ways and Means Committee. We are lobbying the House side of the Environment and Natural Resources Committee. And next we'll be moving more to the leadership. And this is where we need your help to get these bills made into law. If you can please send letters, there is the link. This is going to be put into the chat and it will be in the recording later on. The link here for the Forest Bill's No Water Crisis will go to key committee members and to legislative leaders saying that you want to see these bills that will make these forests into wildland reserves with no logging allowed. You want to see that happen. The second action I would request of you is that you please sign our petition. This has a longer list of forest and urban tree bills that we support, but we use the names on this petition to allow us to get meetings with legislators. What we have found is that if we have enough signers in a legislator's district to our petition, then we can get a meeting, at least with an aide and often with the legislator, him or herself, to have a discussion about why these things are important. So if you will please sign these and share them with your friends, that would be much appreciated. And I will stop here. I'm happy to answer questions as we go on. Thank you.
Thank you, Melissa. That was wonderful. And we will certainly try to have some time for questions, some of which will come to you. And people should know that we will be reaching out with an email to everyone who is registered and given us their contact information. And that will be another opportunity for you to get that information and take action. So we are coming up on 8:30. I'm just going to say a few words before we get into some questions. Knowing that some of you may not be able to stick around for very much longer, SBJE has a very important ask for you, and that is we need you to sign our petition to Governor Healy, which is asking her to use all of her authorities and soft power to get this project canceled. When you sign the petition, you help us in two ways. Number one, your signature will eventually go to the governor. Number two, you will allow us then to communicate with you so that when we need help with upcoming events and actions, we can let you know what's going on and we can supply you with the tools that you need to give us that help. And we will need that help later this spring in connection to a very important report that the developers are going to file with the Massachusetts Environmental Policy Act office. And I will get into that more at the end of the questions. But if you take home just two messages right now, it is let's help trees as a public good with their legislation advocacy, and let's make sure we have you signed up to receive our emails and that your voice is heard to the governor. So now we have been encouraging people to put some written questions in the chat. I have seen those coming along, which is great. So I'm going to ask our fantastic staff member, Laura Sullivan, to read a selected group of questions for as long as time allows. And we've tried to choose those questions that were not already covered by our speakers and which will be of broad interest to the community here. And I'll ask our speaker to respond and to keep answers reasonably brief so that we can cover as many questions as we can in the next few minutes. So Laura, take it away.
Yeah, so the first question I have is from a few people in the chat, and I apologize, I'm going to butcher the pronunciation, but Miyawaki / microforests or pocket forests are a big topic of discussion. What's Dr. Moomaw's thoughts on those in the context of mitigating greenhouse gas emissions and their value compared to other types of forests?
I think these little microforests that are being done are wonderful educational devices, and they really engage people, and especially kids. I mean, they're kid scale, and that probably helps. They may be intimidated by really big trees and really big forests. The total amount of carbon dioxide that they will remove is probably relatively small. But if it gets people to understand that forests are these remarkably complex, interconnected systems and so forth, I think they're a great thing to do.
Thank you. We have a question from Diane. What can we say to our grandchildren about all of this that allows them to proceed optimistically?
That's for me.
Anyone who wants to take it.
Well, I have college-age grandchildren, and this occurs to me a lot because there's so much one can point to that's not going well. but in my own case, I mean, I've been involved in these issues for a very long time as a scientist, it is pretty discouraging when legislation comes along and undoes it all, or an edict comes down and undoes it all. The endangerment fighting, it's not climate, it's not dangerous, it's okay. We can keep doing this. But the way I deal with that is to try to do something. And so, working with Melissa Brown and helping her connect to people and so forth, who are making the political decisions. I discovered I was a terrible fretter. I did not fret well. And so what keeps me going is trying to do something about it. So let me urge everybody to try to do something about it in their own way. Whatever grabs you, go with that one. You don't have to be doing, I don't know, what you think you're supposed to do. Do what you want to do, and you'll make a difference.
Yeah,
That's a
I would.
great answer. Go
I
ahead.
would just add to that. I'm a social scientist, not an ecologist. I started doing this because neighbors cut down to 200-year-old oaks near where I live, and I decided I could either go into despair or I could do something. And so you may not have the time to be lobbying the legislature, but you can sign a letter, you can send it around, you can tell people, you can, I also think that educating children about and colleagues about thinking about trees as a public good, as a shared resource, as beings in themselves, rather than thinking about them just as potential wood products, is also ways to help us move forward.
I love that. Thank you, Melissa. From Melinda in the chat, is there any statewide plan to reduce hardscapes such as huge unused parking lots?
I don't know if there's a plan, but I am struck by the fact that here we are cutting down forests. By the way, I live in a solar house, so I think solar energy is something we really have to do, but I don't think we need to cut down forests to do it. And so we cut down forest out in Berkshire County. Half of all the loss has been for solar arrays. When there are these abandoned malls and mall parking lots just right there, and they're right next to big lines of power lines, So why isn't that a higher priority? And how do we make the decisions? I just don't see our state doing a very good job of that.
So I would say you need to start getting involved in your town. Things about parking lots and is part of zoning and public facilities. One of the things that we can do with urban trees is to allow the stormwater management drainage systems that are often required by towns when there's new construction, to have them calculate in what are the stormwater mitigation from large urban trees and give property owners credit for maintaining large trees on the lot. So it will cost them less. They have to do a smaller drainage system, but also make them have to do a larger one if they cut down larger trees. And there are formulas that this is something that Portland, Oregon has been doing for quite a while, that there are different formulas, whether you're looking at a deciduous tree or a conifer. So these are things you can do at the local level. This is the level of zoning in your town or your city. So call your select board member, call your city councilor, tell them you want to see a change.
Yeah, and then also vote, I would add.
Yes.
Yes. Could I just add just one thing? Most absolutely right. Urban trees, probably overall for the U.S., they remove between 5 and 10% of the carbon of all relative to all 5%, probably more like it. But they are important that's not inconsequential, because we're not reducing our emissions by 5%, right? With technology. the adoption of things and so forth. We're just not doing it, and we just keep increasing it. And so I think that's really important to consider. The problem in towns is that infrastructure takes precedent over trees. All of the towns now are getting, all the trees are getting these V-shaped haircuts with the wires going right through, right? Take all the branches out, taking out a third of the cooling power of that tree, of the carbon power of that tree. And I see it in towns, eastern part of the state, western part of the state. It's just become the, and because it's the, instead of thinking about maybe we shouldn't plant trees right underneath power lines, or maybe what we do is we plant tall trees on the side that it doesn't have wires. We put shorter trees that are only shorter on under the trees. I mean, there are all these things that could be done, and we wouldn't be cutting down so many trees.
Great, thank you so much. So there's another question from Andy, which is how is preserving the trees at Hanscom being communicated to Massport since it is not required in the EIR? And I actually, before I think that there's that there might be a little bit of a misunderstanding in that question because I do think that they address the trees somewhat in the EIR, although it's only a small amount. But I would like our speakers to address this question.
Well, yeah, so I don't, in an environmental impact report, they do have to talk about how many trees are being cut, and they have to talk about the impact on biodiversity and some other things. They don't look at the impact on the ability to produce clean water. That piece is the piece that I was saying that isn't included. So I think having local people say, wait a minute, this is going to affect our water is worth saying, but this is a larger issue that we need to be concerned about with Massachusetts. In September, they proposed changing the MEPA, which is the Massachusetts Environmental Policy Act, changing the regulations for that act so that developers who are going to put in housing can cut up to 10 acres of trees without an environmental impact report. So the governor and the legislature need to hear from people that that's not acceptable, and push back. And we need to let them know that we are concerned about water and remind them that forests in central Mass, in western Mass, in southeastern Mass are not just nice for the people who live there. They affect the water capabilities, the drinking water capacity for the entire Commonwealth, and they also affect near land air temperatures for the area. Bill Moomaw gave me a reference to a study from, I forget now whether it's 23 or 24, that says that Boston is 10 degrees Fahrenheit cooler than expected given global warming because of regional forests. So we keep cutting down those regional forests and Boston is going to get hotter. And we need to start shaking the cages at officials and saying, we're concerned about this, right?
Yes.
Forests affect us all.
Yes.
That's a great answer, Melissa. Okay, so the next question is from Fran. Is there a cost-benefit calculation for cutting trees to install solar? And I think we already covered it a little bit, but I just want to, because I know that this is a question that some people have and would like to be able to address to their neighbors. And so I would love to hear what your perspective on that is.
I mean, there is information that you could put together from existing sources that would give you an answer to that. There was a point a couple of years ago when the state was considering a plan that the state puts out certain subsidies for solar installations, and the idea was that you get different amounts of subsidies depending upon the consequences of putting those solar panels there. So if you cut down a forest to do it, you might not get any subsidies at all, right? Or you might even get a penalty, And so I think that would be a great way to kind of control that and make it. I mean, it wouldn't forbid it because there might be some circumstance where that's the only place you could put it. But I think it would really reduce this to sort of wanting, hey, I can get the money for the logs, and then I can get the money month after month for the solar panels on my land.
Hmm.
So solar, the tension between we have to have solar and forests. There's a wonderful quote
Yes.
from Senator Ed Markey, who said climate can't be either or, it has to be yes
Oh,
and. We
yes,
need housing and trees, we need solar and forests.
absolutely.
And so one of the things that we need to start getting the state to do in regulating, particularly industrial scale solar arrays, is to look, yes, at the carbon and the biodiversity, which they are doing somewhat, but also to look at how is it impacting water. And right now, that is not a calculation that they include. And that, by the way, is a calculation that's relevant for whether or not to decide to put solar on your roof as well. If you have great big massive trees that are diverting thousands of gallons of water out of your basement every year, and reducing your energy costs from the shade if it's on the south, it may be a better calculation not to put solar on your particular roof.
And, and what you do instead is you join you either buy you pay a little extra on your electricity bill to buy solar electricity from someplace else, or I wish we'd have more of these co-ops where 10 families, 100 families, whatever it is, go together and they set up a solar array themselves so that for the people, I mean, probably I'd say a third of houses are not oriented, maybe half houses aren't oriented properly to put solar panels on. What I get annoyed about as a taxpayer is we're paying tax subsidies for people who get panels put on the north side of their slanting roofs because all you do is the area. It's not the quality, it's the area. Same with forests. It's not the quality, it's the area. So we really have to get that right. Yeah.
So if you sign the Trees as a Public Good petition, one of the bills that's in our larger set of legislation is a bill from H3559 S2296 that would give additional subsidies for putting solar on the already built or already disturbed environment, as incentive to have solar developers, because we do need solar, to have solar developers be able to put them on not in forests and on already disturbed lands.
Good.
All right. Well, I think that's all the questions we have time for. I'm going to pass it back to Alex. Thank you so much to our speakers. We really, really appreciate the depth of your knowledge. It's truly incredible. And thank you for coming tonight.
Thank you for having us.
Thank you.
I would also like to thank you for your leadership and for the excellent quality of the information that you've shared with us and the inspiration for people to take action. So, in conclusion, looking ahead to May or June, we will be facing the next major hurdle in our campaign, which will be the submission of the supplemental draft environmental impact report by the developers. We're in the middle of a long process under the Massachusetts Environmental Policy Act, or MEPA, which began in January of 2023, actually. And many of you know the developer's first draft environmental impact report, the DEIR, was roundly rejected by Environmental Secretary Tepper in June of 2024. She found the report lacking evidence to support their claims, lacking credible analysis, and essentially told them they needed to completely rewrite it and to answer scores of additional questions. That redo, called the SDEIR, supplemental draft, is still pending after a year and a half and is expected to be filed in the late spring. It was you and people just like you who played a critical role in this victory for our campaign. Having DEIR reports rejected is a big setback for developers, but it is not, strictly speaking, a permitting process. A huge public response by well-informed citizens is what provides the political leverage we need to ensure the project is canceled. So when we need your help again, you will hear from us, and we will provide you with a nifty toolbox of analysis and templates you can use to make your comments have high impact. And in closing, I would just like to say this was a wonderful moment of community. And as some of our speakers have said, these are tough times we're living in. It can be very discouraging. There's bad news on many fronts. But I'm also thinking about the people that we're seeing out there, whether it's on the front lines in Minneapolis or other places where regular citizens are getting together and acting collectively and supporting each other, that amazing changes are happening. And I think that is the solution for our mental health as well as for the problems we're facing. So join us, go to spje.org, sign our petition, and you will be part of this community going forward. And you can also support the wonderful organizations that are part of our coalition. And again, thank you for coming, and stay with us, and sharpen up your pens and pencils for May and June, and we will be back in touch. Thank you so much, and good night.